We want to follow on now and consider the heart and the chambers and valves in the heart in relation to the systemic and the pulmonary circulation. The systemic circulation going to the body, the pulmonary circulation going to the lungs. Now, if you've watched the previous video, you'll be aware that that is the mitral or the bicuspid valve pointing down the way. And you'll be aware that that represents the pulmonary veins. Left atrium, left ventricle. That would make this the aortic semilunar valve, and this vessel coming out here, the aorta. This would represent the inferior and superior vena cava, the right atrium and the right ventricle. That would make this atrioventricular valve here pointing down the way. That would make that the tricuspid valve. This would be the pulmonary arterial semilunar valve pointing up the way into the pulmonary artery. Now, the left ventricle has got a thicker myocardial wall because it has to pump blood to all of the systemic circulation. And the muscle in the septum is also heavily involved in generating this contractile force. The right ventricle has a relatively thinner muscular wall because it only has to pump blood from the pulmonary artery to the lungs, and that's not so far. The atria also has a myocardial wall, but again it's thinner because that's just pumping blood from the atria down into the ventricles. Now, the aorta will divide into smaller arteries, and this will take blood to all of the body. So we can represent that like this. This is the body. So that's your brain, your kidneys, your liver, all of the major organs. And once the blood has circulated through the body, it's going to return via the inferior and superior vena cava, draining back into the chamber there, which is the right atrium. So the left side of the pump, or the heart acting as a pump, the left side is the body pump, pumping blood to the body into the systemic circulation. Now, the right atrium, the right ventricle, that's the right atrium there. The blood goes from the right atrium to the right ventricle. When the right ventricle contracts, the blood is ejected into the pulmonary artery, and that's going to take the blood to the lungs, which we can represent here. So here we have the lungs. It is the pulmonary arteries that are taking blood to the lungs in order to be oxygenated. As the blood goes through the lungs, it's going to be oxygenated and give up its carbon dioxide, or most of it, and then the blood is going to drain back via these pulmonary veins back into the left atrium. So there we see the full circulatory system in all its splendour and yet great simplicity. Now, the blood in the left ventricle is going to the systemic circulation, so that's going to be bright red. It's going to go through the aortic semilunar valve into the large arteries. As the blood pumps into the large arteries, they're going to dilate, and then elastically they're going to recoil down, smoothing out the blood flow to the body. So oxygenated blood is going to go into the systemic circulation to all parts of the body, and when it arrives in the tissues of the body, it's going to be highly oxygenated, therefore bright red. But as this blood goes through the tissues of the body, the percentages of oxygen in it are going to be reduced down to 70 to 80% saturations. And the blood is going to appear dark red because it's carrying less oxygen. Now, traditionally, when we're doing physiology, the dark red blood we do as blue. It's not blue, of course, it's dark red. But the blood is going to become darker red as it goes through the body. Then dark red blood is going to drain in the large veins, eventually going into the inferior and superior vena cava, taking blood to the right atrium. This deoxygenated blood will then go through the tricuspid valve into the right ventricle. When the right ventricle contracts, that blood will be ejected out into the pulmonary artery, and it is the pulmonary arterial system taking blood to the lungs. So when the blood arrives in the lungs, it's going to be dark red, relatively deoxygenated blood. As it goes through the lungs, it's going to become progressively oxygenated, and it will progressively become brighter red until it's 95 to 100% saturated. And then this bright red blood, rich in oxyhemoglobin, will go back in the pulmonary veins, a vein being any vessel which carries blood back towards the... There's actually 4 main pulmonary veins in humans, carrying the blood back into the left atrium. The blood will go from the left atrium through the mitral or the bicuspid valve back to the ventricle, which is where we started this account. So the circulation of the blood, in essence, is very simple and very straightforward, and yet a very intricate, well-designed, parsimonious system of circulation. Now I've got a diagram here which shows us a bit more detail on how this circulation of the blood works. So I'm just going to put that up there and we'll have a look at it. Now I think we'll start with the heart here in the middle. And again, if we start with the left ventricle, which is this chamber here, that's going to pump oxygenated blood into the aorta. And some of that blood is going to go to the, is all oxygenated blood here. Some is going to go to the arms via the brachial arteries. The large artery in the top of the arm is the brachial artery, carrying the oxygenated blood to the arms and the hands. Of course, as that goes through the tissues, it will give up its oxygen and become deoxygenated and will drain as dark red, partially deoxygenated blood into the veins. We notice one of the large veins in the arm is called the cephalic vein, and that is eventually going to drain back into the superior vena cava to go back to the right atrium. And we notice that other blood from the aorta is going to go up towards the brain and the head. 2 of the large arteries carrying blood towards the brain are the carotid arteries that you can feel pulsating in the neck. This is going to take oxygenated blood to the head and indeed to the brain. Again, as that goes through the tissues, it's going to become somewhat deoxygenated. It's going to become darker red. 2 of the large veins in the neck are called the jugular veins. They're going to bring the blood back down to the superior vena cava, back to the right atrium. Now from the right atrium, the blood's going to go through to the right ventricle and from there to the lungs. And as the blood arrives in the lungs, it's going to be dark red, deoxygenated. But then as it goes through the lungs, it's going to become oxygenated and bright red again, draining back via the pulmonary veins to the atrium. Sorry, to the left atrium, ready to go to the left ventricle to be pumped out again into the systemic circulation. And we notice that blood also goes down through the body towards the liver, and it's the hepatic artery that's taking blood to the liver. Again, as the blood goes through the liver, it will be partly deoxygenated, meaning the hepatic veins are carrying deoxygenated dark red blood back, and in this case it's to the inferior vena cava, which is also draining back into the right atrium, ready to go to the right ventricle to go back to the lungs to be oxygenated. Now, oxygenated blood is also going to go to the organs of the gastrointestinal tract, and one of the vessels involved there is the mesenteric artery. That's going to take blood to the gut. This tube here represents the gut. So the oxygenated blood will go into the gut, the gastrointestinal tract, and it will become deoxygenated. But here we notice a very interesting thing. This blood does not drain directly back into the venous circulation. It drains via this small vein here directly into the liver. And this is the hepatic portal vein. Because we don't want bacterial breakdown products and we don't want digested food going directly into the systemic circulation. We want it to go to the liver first where it can be processed. So this hepatic portal vein is unusual in that it begins and ends with capillaries, ending with capillaries in the liver. So the hepatic portal vein is taking blood from the gut directly back to the liver for processing. Other blood goes down through the abdominal aorta to the kidneys. Again, going through the kidneys, giving up some of its oxygen, draining into the inferior vena cava. Other blood goes down arteries such as the femoral arteries to the legs, giving up oxygen to the tissues of the legs and draining via veins such as the femoral veins back into the inferior vena cava to go back to the right atrium prior to going to the right ventricle, prior to going to the pulmonary artery, to going back to the lungs. So there we see a little more detail about the nature of the circulatory system, with some of the names of the major blood vessels involved, taking blood in arterial vessels away from the heart to the tissues and returning blood from the tissues to the heart in the veins.